y minus y hat. We'll put it in words too, because I'm worried. Guess what could happen in a testing situation? It can happen. You mix it up. You go, ooh, is it y hat minus y, or is it y minus y hat? And you get all confused. So let's put down some words here with this. How about this is the actual y value? That means the actual y from the table. Or the observed y, as you indicated earlier. And then this is the predicted y. So people use methods like this to help them remember this so they don't confuse it during a test. That starts with an A. That starts with a P. Okay, A minus P. You can think of Associated Press. You know, words like that. If you like athletes, Adrian Peterson, a great running back from the Vikings. I mean, anything like that to help you remember. A minus P. Cool? Actual y minus predicted y. So I'm going to ask you to find it for one of these values. I think I'll do that value. Let me go look to see what that value was. Let me hit trace. I'm going to hit on. I'll hit the light so you can see that. I'm going to trace to see which data I'm going to ask that question. We're going to find the residual for this value here. Let me hit trace. Boom. All right. 103, 274. And when you and I are going to find the residual for that data value right there, we're going to find, what's that little... How far is that? It's going to come out positive, isn't it? Mm-hmm. Everyone agree? Good. It's going to come out positive. So we don't need this for now. Turn that off.
Is the values on the line?
Ooh! What do you think the residual would be? That was good. Is that you, Liz? What do you think the residual would be when the value is exactly on the line?
0.
0. Because it really means like, residual means like left over, like how far away. You're like, oh, well then it'd be right on the line, so your residual would be 0. A lot of these residuals are very small, aren't they? When we come up with this. So, all right, we're going to determine the residual. For well, I'll just say if the club speed is, which one did I choose?
103, 274.
I'm going to circle it. We're going to find the residual for that one. Determine the residual if the club speed is 103 miles per hour and the distance equals 274 yards. All right. And it's y minus y hat, right?
Mm-hmm.
All right, so we're going to find this. Y minus y hat. Actual y minus predicted y. Okay. What's the actual y?
274.
I love it. Everyone agree? That's the actual y. That's the observed y. That was that golfer's y. That was his distance. 274 yards. Now I'm confused. What do y'all think? How am I going to get this?
You have to plug 103 and the...
It just says y hat, right?
Yeah.
We need the equation, don't we? We need the equation, all right? Now, I'm okay if you just go out to 3 places past the decimal point, but the more accurate, you know, of course, the better if you use all the digits of accuracy. So I'm going to need that equation right there. I'm going to write it out. 2.166. And then there's an x. What should I put for the x?
103.
I love it. Feel how that was? Everyone says for the 103, I mean for the x value, you're going to substitute the 103. And right there at that x, you're like, oh, I'm going to take this 103 and do what? Substitute it, so I'll put 103. And then there's a minus what? In fact, just put a times. How about that? Minus 55.797. I have a math here on the board.
Parenthesis.
Someone, would you highlight this? It's the old order of operations. What's wrong with all that math?
You can add either a plus after the 55.797 or parentheses.
Brilliant. Everyone, I have to subtract that quantity, don't I? I have to subtract all that. So I could put parentheses here, or what a lot of you do, which is very smart, you find that number first. You're like, wait a minute, what I'll do is I'm gonna find what this value is first. It's gonna be very close to a 274. I'll find out what it is on my calculator, and then I'll subtract 274. Cool. And if you wanna use all the digits of accuracy in that calculator, you can use that as well. But we're like, oh, I'll just do this. All right, 274 minus, let's see what I get. Well, there's two ways to do this. One way is manually, right? And when I'm going to do the second part first, I'm just going to do blank screen. Look, blank screen. I'm just going to type out, what is this number right here? I know it's close to 274. It's right near it. So I'm going to do 3.166 times 103 minus 55.797. And what do I get? 270.3. Very close to this. And then I'll subtract them. And this is going to come out positive in it.
Mm-hmm.
This is my residual. Here it comes. What's left over? How far?
3.7 miles per hour.
3 point...
I got 69.
Hey, does anybody use the ants button? 274 minus, I don't feel like typing that, so I'm just going to hit ants. You know where ants is? Second negative. I just don't feel like typing 270.301. I might mess it up. I might accidentally write 273.0, so I just go ants. Last answer on the calculator. Then I get 3.6. 3.7. Will that work? 3.699, 3.7. Hey, if you want, do you remember this? Was there a way the calculator can just tell me the value on that line at 103?
Mm-hmm.
Is there a way to do it? Yeah, I'll show you that too. So what I could do, everyone, remember all that math I did to get the 270.301? Well, here I got my picture, but I wouldn't need my line there. Was my line in there? Yep. And is it good? So I have my line there. What I could do is, have you ever gone to the menu second calc? You hit second trace. It's the calc menu. Don't worry if you don't want to do this. We just did it manually. But if I go to trace, which is second calc, what's the first thing say?
Value.
Value. So you don't have to do this because you just saw we did. If I hit value, now the cursor's blinking. I want the value on that line at what value?
103.
And I hit 103, I'm like, could you just tell it to me? What's the value on that line at x equal to 103? Oh, thank you very much. And it keeps all the digits of accuracy. So there's way, just like, you know, any of you who use like apps on your cell phone, this thing will actually keep it all nice and accurate if you like that. But I know also you're like, well, I could just do it manually. Right? He said go up to at least 3 decimal places. Cool, so there's that number. But that's not the real data beta, that's the predicted value, right? So that's see how it makes a marker right there? And what we're doing is we just said, how far is that from that? Subtract y minus y hat. Cool. Cool, all right. Awesome. Hey, that wasn't too hard, was it? Hey, I'm going to finish out a few more questions. And then I say we go back, and just for extra practice, let's find all the residuals. We found this residual, what was it?
3.7.
Yeah, 3.7? Let's go and we'll find all the residuals. Let's see, and we can talk about that, like how that can be helpful. Residual is the distance from here. And when they call this line right here, the regression line, they also call it the least squares regression line. I'm sure you're curious about that. Why do they call it least squares? What the heck does a square have to do with this, right? So I wanted to let you know, if you're curious, if I found this distance right here and I made a square, and then I did it here with that residual and I made a square, and I did it with this one and I made a square, and I did it with that, well, that's going to be a small square, that's going to be a small square. Well, this line is formed such that the sum of the areas of all those squares is the least. That's the way that line is designed, through the math formula. So that you sum up all the areas of those squares, that summation will be the minimum. Isn't that cool? That's why they call it the least squares regression line.
So does it come to 0 or something?
It will only be 0, that sum, if all the dots were right on the line.
Okay.
But it gets minimized. Just like in calculus when we do what? Optimization.
Okay.
So the more, like, if this line got bent a little bit more this way or that way, and there's applets for this, you could check it out. The sum of all those squares, you would see it would be a little bit higher. Isn't that cool? That's how it's really designed by that formula. But that's why they call it the what? The least squares regression line, if you're curious about that. I just want to let you know. Why do they call it that? And so the summation of all those areas is the least. All right. So I'm going to go to a letter F. Great job with that. And I bet you know this question. That one is the distance in part E, that was our last question, is the distance in part E at 274 above or below average?
Above.
And you're just going to put above or you're going to put below. So I've called this the least squares regression line. Sometimes I just call it the regression line. But feel free to call this the line of averages. You can think of that as the line of averages. So, think about this question. Is that distance in part E, the 274 yards, what do you think? Is that above or below average?
Above.
Above. Well, we can see it. It's above the line. But everyone, let's say you're blinded and you don't see the line. How could you know from this previous answer whether it's above or below?
Positive.
Oh, you're great. If it's positive, if your residual is positive, it'll be above average. If your residual is negative, it's what?
Below.
Below average. So you can do all these problems, Michael, without even seeing the graph. You're like, oh, I got a positive residual, it's above average. So I'm going to put above. It's above average. It's above average. So that's how residuals can be helpful. You can tell us whether it's above or below that line of average. Cool. Hey, a couple more. Looking over here, okay. On a 99. Hey, my friend's a golfer, and he contacted me. He knew about this study here, because he heard me mentioning this to him last week, and he goes, hey, I just hit the golf ball, and he hit 104 miles per hour. There's a radar gun at the golf course, right? So, my friend was asking me to use the regression line to make a prediction. For the distance. For 104 miles per hour. What is that distance? All right. What is that distance? So again, let me tell this story, everyone. My friend, he knew about this study. He heard me talk about it. Well, he's at the golf course the other day. There's a radar gun at the golf course. He was clocked at 104 mile per hour club speed. And the ball went fairly straight down the, down the run. Whew. Can we estimate his distance? Because he couldn't see it, right? He's like, man, that ball went far. So we can make a prediction of how far that ball traveled. What would I do?
Plug in 104 at 3, the y hat.
Yeah, I love it. I'm not going to use the residual equation. I'm just going to use the what? The actual y-hat equation. I'm just going to go up here and substitute right there. That 104. So we can do it two ways, right? I can sit here and manually do what? Okay, let me just see. What's 3.166 multiply 104 minus 55.797? Or, if you have all that stuff in your calculator, you can use the value button. But hey, that's not that bad, right? I'll just type that out. 3.166 times 104 minus this. I'm going to give it a rough estimate. All right, what is it? Let's see. What does that come out to be? 3.166 times 104 minus 55.797. So I want about 273 yards. Right? So we're getting about 273.467 yards. Hey, anybody, I'm curious, anybody use the value button? Watch, don't worry if you didn't, because I didn't use it right there. Who used the value button? I'm just sure. Ooh, a couple people like that. Go ahead, Liz.
Just out of curiosity, based on the table, why would that value be lower than the speed of 103? 'Cause I just kind of looked at
I like that. So here's the line, the regression line, the least squares regression line. We found the value right there. And I want you to see it on the line. So I'm pointing to it here, Liz, but I'm going to get it on the calculator. I want you to see this 217.467. So I'm going to go into my calculator. I'll just clear that out. I'll hit that graph so I can see it. And I'm going to go to second calc, and here's that button value. I'm like, all right, could you show me the spot on this graph? It's going to be on the line at 104 miles per hour. And there it is. Okay, so at this extra 104 miles per hour, the Y value is taken on 270.47 yards. You're curious because, go right ahead,
Yeah, I just kind of made a quick estimate. They have the distance, I'm sorry, between 103 and 105.
good, I'm going to find them right here, right?
Right there, yes, and very, yes.
So when she's noticing, look,